Holy boys, the stream crashed. Actually, my entire computer crashed just like a second ago when I last tried to stream. But we'll see, we'll see, we'll see, we'll see, we'll see. Are we back online? I think we're back. I think we're back, boys. Anyway, so I'm doing this to keep myself accountable. Yeah, let's go and yep. Ooh. Capture. Right. Hello, sir. Working on something. Working on something. Working on something. Hold up. Give me a second. Uh, we are working on something, dude. So, hold up. Trying to get everything real cool for us. Yeah, it's working. That removed the face cam from there. I'm trying to get this working, dude. Why is it not working? Let's see if I were to do it like this. Huzzah! I got it running. Woo! Okay. Get that out of there. Okay. We're plugged in there. Plug her in. Why it no work? Why it no work? I'm trying to get this capture card running real quick. Sorry. You know, I should probably do this off a stream. Okay, well, try it out. Can you guys see what I'm doing here? Isn't it fascinating? Isn't it isn't it just wonderful? Are we in? Why is it no working? Why is it not working, dude? This is annoying. That's why, because we have our input into our output section. That makes a lot of sense. Let's see if it works now. Um, we now have it into HDMI input. This should just be picking it up. Come on now, dude. Ah, we got it. Huzzah! Okay. So, yeah, now we can do everything. But, yeah, so we have our little screen here. We have our little marker. Can you guys see what I'm doing? We doing cool stuff. Okay, hopefully you guys can see what I'm up to. But yeah. Okay. Sweet. Okay. Let's see what this changes. Avidly nothing that I want. Let's just go screen. Admittedly, we got some other stuff we need to work out here. Hi friends. Yeah, we got some more stuff we got to work out on this end. This this end of the scenario. Shit streamer me. Capture card. Like, why is it not just like... Let's see, what did that do? It's like freeze framed. Huzzah, I got it working. Huzzah. Okay. Pretty cool, pretty cool, pretty cool, pretty cool, pretty cool, pretty cool. We're gonna do something I never thought I would be doing. We're gonna go sideways with it. Okay, 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 okay. Okay, we got everything running now. We're just going to finish up everything we have to do to set up real quick. So it's not gonna be too bad. So yeah, let's we're gonna finish all the warm-up stuff, or yeah, we're gonna have to finish up all the prep work that we're doing right now. So yeah. Doing it, boys. We're doing it. We're doing it. We're doing it. We're doing it. We're importing it. Oh, I forgot. It's quiet in here. Let's get some audio going. What do you guys want to listen to? Let's go for inspiring. Jeez, that was loud. Holy. What's the audio at? Yeah, we gotta tweak that down ever so slightly. No, that is also way too loud. We'll go to like here. Let's go with some lo-fi. Not my vibe. Okay. We're heating up, boys. We're heating up. We're just gonna Okay, I think we're ready to begin the study session. So this is our practice test, and we're just gonna get right into it. Let me, real quick. Hey everyone. Cool. Sweet. Get this going. Okay. So we have this physics problem, and we're just gonna solve. Hold on, let me tweak the music slightly. It's still a little too loud. Actually, I just don't think I think I just don't like that song. Anyway, so we have this this 4 kilogram block. Has V sub I meters per second, and then it's at this 20-meter incline. I mean, 20-degree incline. It is angle 20. Okay, so so we know that, well, to go up this incline, okay, sweet. So anyway, we know to go up this incline, well, okay. First, let's say what this is. This is not a momentum problem. this is a work problem. So we could set up the equation work F other is equal to 1/2 MV final squared plus MGY final minus 1/2 MV initial squared plus MGY initial. And this is going to be our beginning algebraic expression, and then we're actually given a component of work F other here on the side. So we know what this is. We know that this is composed of, it's going to be the magnitude of the force, which is 15, right? So 15 newtons. So 15 newtons. Then it's going to be times the distance that it travels, times cosine of 180, because the frictional force always goes against the movement of the object. This just becomes -1 because it's cosine of 180, so it just becomes -1. And we have 15 newtons times d is equal to no, this is, yeah, this doesn't look like the best -1 ever, so this is just going to be -1. Then it's going to be this algebraic expression, duplicator, put it here, and then let's just plug in some of our values, why not? So 4 kilogram block, initial speed, up at 20, okay, so we know MGY initial is 0 because our Y initial is 0. We don't know what our Y final is. And we know what this is. Or we know what this is right here. So, and then we're trying to find this. And we actually know that this is 0 because it's what will happen when it starts moving up the ramp, right? How does, oh yeah, before stopping. So yeah, so before stopping, so that goes to 0. And then now we just have this wonderful expression, 15 newtons times d, or -15 newtons times d, is equal to MGY final. And we'll substitute in our values. So we know it's a 4 kilogram block moving at 8 meters per second. So it's going to be 4. And then it's going to be times gravity 9.8 times Y final minus 1/2. So we'll just write it like this. And then we know our mass is 4 once again. And then we know our velocity initial is 8 squared. We're going to end up getting 64.
This music is way too loud.
I'm sorry, I'm looking for something piano. Okay, this is a little bit better. Anyway, so, well, we know that this is just some number. This is just some number. This is some value of y final. And then we have a force, and then we don't know what d is. We're trying to find out what d is. Anyway, so what relates... So, okay, this block is going to go up this incline to, say, this point right here, right? Which its velocity is now going to be 0. Let's 4 kg, a sloppy kg, we'll fix it up. So it goes up the incline, 4 kg, and well, what do we know about this y final. This y final is going to be our height h at which it stops. And what else do we now know about this displacement d? Well, anyway, so we're going to get the algebraic expression, so katoa, so sine, and then opposite of the angle, which is going to be our h value, or y final, over our displacement d, because displacement d is the hypotenuse in this case. So it's going to travel it up, some displacement d. Wait. Sorry. Sine 20 is equal to y final over d. And then now we can solve for this algebraic expression with one of our, now we can solve for this expression using what we know. And we know that we know that we're trying to find d. So we're trying to find d in this problem. So we're gonna we're gonna do this with the laws of algebra, multiply both sides by d, and then divide both sides by d, so we'll get d is equal to y final over sine of 20. And then now we can plug in this number back into our equation over here. So it's going to be negative 15 n times d is equal to 4 times, actually no, 4 times y final over sine 20 is equal to 4 times 9.8 times y final minus, and then we're going to use a calculator to get this value. So out from there, then we go 4 times 9.8. No, 4 times, I'm sorry, 64. We'll get it to be 128. So now that we have that it equals 128, we're gonna solve. So we're gonna try to get our y final on both sides. So simplest way to do that is, what is the simplest way to do this? Okay. Let's say y final over what is the easiest way to solve for this algebraic expression? Well, no. So we're not going to want to do this, because that means we're going to be solving for y final. So that's still correct, but instead we're going to plug in y final over sine 20. Yeah, sure. Why not? Whatever. We'll solve for y final. Doesn't matter. Anyway, so laws of algebra. Y final over sine 20 plus 128. Actually, no, we're gonna keep it on the other side. So what we're gonna do is, okay, better idea. We're gonna make these actual values. So Okay. So dividing anything by 1 over, or multiplying anything by 1 over sine 20. 1 over sine 20. I am in degree mode. Is, so it's going to be like 2.9 something y final. So we're going to actually keep that value the same. So we're actually going to do the math. 4 times 9.8 is 39.2. So we have 39.2 y final minus 128. And then we have y negative 15. Then we have y final over sine 20. Okay, divide both sides by 15 and subtract negative, or okay, so we have y final over sine 20 minus 39.2 is equal to positive, because it's going to be negative 15, or negative 128 divided by negative 15. Y final. So we're going to have minus 128 divided by minus 15. Okay. Is equal to that number. 0.53 repeating. So that's 8.53 repeating. I don't like how I did this. I really don't like how I did this. We're gonna go back on everything we've done so far. We'll go back to, let's say, this part. Actually, no, I like that. I like a part of that. I don't like that. Okay. So what can we do here? Divide both sides by negative 15 is a possibility. Okay, yeah, we're gonna divide both sides by negative 15, and then we're gonna multiply by y20. So y final is equal to 39.2 minus 128 over negative 15 times sine of 20. Well, actually, okay, let's write this. Let's write this separately. 39.2 y final over 15. $128 over 15. One final. .53 repeating. Okay. So let's take this number, let's add it to this number. No, that does not exactly work. Okay, so we'll just move this over. I don't want to multiply this by y. Okay, whatever, we'll multiply it by sin 20. Sin 20. So we have y final to negative 0.89 y final plus sin 20 2.991 2.92. Add that to both sides, so we have clear. We have 1 minus of that, so we get 1.89 y final is equal to 2.92. Divide both sides by that number. And we get y final to be about 1.54 meters.
And then now we're gonna check to see if that is true, because we also did this yesterday.
So we actually already took this practice test yesterday. 4.51 meters, huh? Times sin 20. Oh, this is okay. So we calculated for y final here. So this value is our y final value. So now we can plug it in and solve for d. Okay. So now we get d is equal to this. Ooh, sorry, let's just grab what we need. Can I just paste, divide by negative 15. Let's just make this 128. Okay, cool. Sweet. So now we're gonna plug this into our calculator. 4 times 9.8 times that number. Over minus 15. And then we get our d to equal about 4.51 meters, which is correct. Wow. Man. 4.51 meters. Yep, so that is correct for solving for distance, but there is a part 2 to this question. Once the block stops on the incline, will it slide back down the incline? So what we can do is we can set up a force diagram for this. And then we have free body diagram. We have our normal force pointing straight up. And we have our frictional force. Actually, technically in this case, frictional force is going like that. Then we have our gravitational force, or we have our weight force going like that. And then now we can now split up the components. So we know force of friction is going to be 15 newtons. So it's going to be 15. Well, okay, this is actually just the force of friction. So yeah, okay. So we know that it's 15 newtons. And then we can split mg into components. We know our mass. We also know our angle theta. So we're going to write it in red here. We know our, well, okay, we know this leg to be mg cosine 20. And we know this to be mg sine 20. mg sine 20. And honestly, all we need to know here is this mg sine 20. And then see if it's greater than 15. So we're going to do 9.8 times 4 times sine of 20. And then, so, which equals 13.41 newtons. That's newtons. So B, no, because the force of friction is larger. So it's not going to slide back down. Fun fact. I got my pencil stuck in my hair. Ah. Okay, so that's question 1 done. Question 1 took us a good amount of time. Let's see how long that we've been on live for. 37 minutes. Yeah, question 1 took us quite a bit. Anyway, question 2. A skier of mass 65 kilograms starts from rest at the top of an incline of height of 20 at a height of 20 meters, as shown in the figure below. Coefficient of kinetic friction. So we're given the coefficient of kinetic friction, and then how far does the skier travel on the horizontal surface before coming to a rest. Okay, so in this case, we're going to need 2 equations. So this is going to be the same work equation of, it's going to be the same work F other equation. So our energy is not conserved, so work F other is equal to 1/2 mv final squared plus mgy final minus 1/2 mv initial squared plus mgy initial. Ow. Yoinks. Ow. Sorry, a little itchy. Okay. And then we're going to need this type of equation twice. But it's cool. We're going to just use our intuition to solve for the first one. So we're given mu sub k, so we're going to need to solve for the normal force, which is no problem. So in order to solve for the normal force, all we're going to have to do is set up a force diagram. And we know normal force is always perpendicular. Is always perpendicular to the ramp. We have our weight force going this way. So our normal force in this case will be equal to, in this case, it is going to be equal to mg cosine 20 so it's going to be 0.2 times mg cosine 20 times displacement d. Actually, yeah. Times displacement d. Sorry. Times displacement d times cosine of 180, which just goes to -1, is equal to 1/2 mv final squared minus 0, because since we're setting our y-coordinate system here, this is 0, so if your y final is 0, then everything, this entire thing, expression, just simply goes to 0, so mv final minus, and then we have this goes to 0 because we're starting at rest, minus mgy initial. And then we want to find displacement d, and then, so, okay, we're going to also use SOHCAHTOA here, so d is equal to sine 20 up, d is equal to 20 over sine 20. Yeah. And let's just find out, yeah, we could just plug that in now and find out what that is. What is 20 divided by sine 20? It's going to be about 58.4. 58.48. And when we actually solve this equation in our calculator, we're going to end up using this value as d. So don't worry, this d is not going anywhere. Okay, anyway, so we're going to solve for this velocity final, and this velocity final will be our velocity initial starting from here. So, like right here, it's going to switch to v final of equation number 1, and then here is going to be v initial of eq number 2. So, plugging all of our stuff in, we're going to get 0.2 minus 0.2 times, what is our mass? 65 times 65 times 9.8 times cosine 20 times d, which d is equal to this, minus 65 times 9.8 times 20. It's actually plus. And then it's going to be all of this times 2. And then divided by 65. And then we're going to take the square root of whatever number that is. V final squared. Okay, long algebraic expression going into the calculator. So it's going to be 2 times minus 0.2. That's going to be 65 times 9.8 times cosine 20 times plus 65 times 9.8 times 20 over 65. Then we're going to take the square root of that number. And then we're going to get V final is equal to roughly equal V final 1 is equal to about 13.29 meters per second. Need some water soon, dude. We'll get some water after we finish all 4 of these problems. Anyway, so that's V final for equation 1. And then mu sub k is also 2 for that. So, okay, this gets slightly easier now. So we know mu sub k is going to be 0.2. And then now we know our normal force is just equal to mg times d. It's going to be d2. That's d1, by the way. This is d1. Times d2 times cosine of 180, which just goes to -1, is equal to V final squared. 1/2 m V final squared, sorry. Half mv final squared. Gy final is to 0. That goes to 0. That also goes to 0. So we'll get d2 is equal to just mv final squared over 2 over 0.2 times mg. And then we'll get d2 to be okay. We'll get 65 because his weight doesn't change times squared divide by 2, then divide by 0.2 times 65 times 9.8, and we get d2 to be about 45.05 meters. Then let's do a quick double check. Our papers almost went everywhere. They pretty much did, but I caught most of them. Yep, 45.05 meters. Sweet. So yeah, we got 45.05 meters. Number 3, particle of mass m is... Okay, so the key to this problem is that it's frictionless, meaning energy is conserved. So that we know energy is conserved, we're going to want to know determine the, okay, shown on rest, release from point A. It's released at point A, so I'm guessing that it its initial is gonna be 0 because it's released at that point. Just also highlight U. Okay, so now, so the thing is for conservation of momentum, well, mg v final squared over 2, not mg, it's just mv final squared, mv final squared over 2 plus mgy final is equal to, it's equal to the initial. Duplicate. It's equal to this, but let's plug in our i's. Our I. So we know that for that problem. So the only thing that's really going to be changing is, well, our velocity final at the different points, because that's what it's asking. Anyway, so let's say from A to B, we have a particle of mass m. Are we given the mass of the particle? 5 kilograms. So we get this expression. Five times 9.8. Yeah, I mean, that looks good. So then, sorry, excuse me. We get v final squared is equal to 5 times 5 times 9.8 divided by 5 times 9.8 times 3.2 then times 2, then divided by 5, we get v final squared is equal to so 5 times 5 times 9.8 divided by 5 times 9.8 times 3.2 times 2 divided by 5 what? Okay, that doesn't seem correct. We'll do this one at a time then, because that did not seem correct. Okay, 5 times 5 times 9.8, we get 254. Let's now divide this by 5 times 9.8 times 3.2. We get 1.5. 1.5 times 2. We get 3. Divided by 5. Okay, we get v final squared of 0.625, which means v final is equal to the square root of that. V final is 0.79 meters per second.
Let's verify this, because this seems very suspicious. I'd like to see if I'm doing this correctly. What? Oh, that's why. Okay, I'm an idiot. I am such an idiot. This is a addition sign, meaning that we're going to have to subtract this from that value. Sorry, we're going to have to subtract this from this value before we divide and multiply, or multiply and divide. So let's do v final is equal to, because we'll do it 5 times 5 times 9.8. Then we'll do minus 5 times 9.8 times 3.2. Okay, now we're going to multiply by 2, divide by 5, and take the square root of that number. And we get v final to about 59 point... Oh, no, we'll get v final to 5.94 meters per second. Anyway, so now we're just going to set up another algebraic expression like this. So now b to c, we're going to get 5, which is the weight, times 5.94. Oh, see v final b. V final b squared divided by 2 plus, it's going to be 5 times 9.8 times 2 is equal to, nope, it's going to be v final c. Now this is 5 times v final b squared over 2 plus 5 times 9.8 times 3.2, and we'll get v final c is equal to, let's solve this out real quick. So alpha here, 5 times 7.6 meters per second. Let's see if that's correct. .6 meters per second. Cool. Facts, we like that. What was the work done by the force of gravity in moving from particle A to B? Okay, well, we can just do... Well, it's just going to be mgy final, mgy initial. Wait, no. It's going to be... Well, no, it is going to be this. Yeah, it is going to be this minus this, right? Yeah. It's going to be 5 times 9.8 times 3.2. 5 times 9.8 times 5, which... Is this Silent Night? Dude. Heat. Heat, dude. Heat. Absolutely fire. Did I do this directly? Oh yeah, but it's gonna be positive. Forgot, because work is gonna be positive. Anyway, last problem, and then we get to have some water. In a particular crash, automobile crashes and collides with wall. Final velocities. So, okay, this is J is equal to delta P. Anyway, we'll get J is equal to MV final minus MV initial. J is equal to 1500 times 0.6 plus 1500 times 15. J is equal to 1500 times 2.6 plus 1500 times 15. J is equal to 2400. And then this is going to be in... It's going to be in Newton meters, right? Yeah, I think it's in Newton meters. I really do think it's in Newton meters right now. Yeah. Okay, and the collision, what's the average force? So, if you didn't know this, J is equal to F average times delta T. So, 1600 newtons. Let's see if this is correct. What? I'm off by... Oh, I wrote down, this is incorrect. This is 26,400. I forgot to write down the 6. Let's see if we're correct now. Okay, yep, we are indeed correct now. Okay, we've finished this, the practice test for like the second time. So, yeah, we're gonna take a little water break, a little bathroom break, and then we're gonna get back to it. Yoinks! Little bathroom break time. We'll be right back. Sweet. Okay, we're back. We got some nuts and some agua. So we're gonna drink some water, have some almonds. I really like Smokehouse almonds, the Blue Diamond ones. I'm buying them in bulk from Sam's Club. We got some quotes up on our wall. That's if you see the yellow sticky tag. Some of the ones we got are, and yet it moves, Galileo Gallinari. I think, therefore I am, Descartes. If I've seen further, it's by standing on the shoulders of giants, Isaac Newton. I think, therefore I am, Descartes, part 2, second time. I wrote it down twice, I like it. An equation for me has no meaning unless it expresses a thought of God, Ramanujan. And then Archimedes, give me a lever and a place to stand, and I shall move the earth. We're gonna have 3 more almonds and then pack it away. Okay, gonna go wash my hands. I'll be right back. I'm not even gonna put up the be right back thing because it's really quick. Lightning fast. We have extra water, by the way, so if you see them down here in the border, you knew today was going to be a long one. Let's open up the window. Get some fresh air. And we're gonna get some more practice problems loaded up so that we can work some more. Wait, what? To verify something. Okay, I have to send an email to my professor. Hold up. Okay, professor. We're just gonna email my professor real quick and then we'll get back to it. I know why I got this quiz question wrong. sorry. Emailed my professor, and we should be all good with that. The reason why is I wanted to verify I was incorrect on this question for the reason that I'm thinking. So we're gonna screenshot all of our past quiz questions in here, and then we're gonna be redoing them.
Okay, we've set it up.
Okay. Why doesn't this thing want to work? Let me get this working real quick, once again. Everything's very plugged in. I don't understand why it just randomly stopped. Give me a second. Can we get the capture card to work? Can you start reading? Hello. Is your card? Come on, dude. Why is this thing giving me so many stupid problems? Dude, why is this stupid thing not working? Do I have a weak connection to any? Does that explain it? My HDMI wasn't fully plugged in. Haha! I was right. HDMI was not fully plugged in. Or it kind of like maybe got like a little disconnected. So anyway, so yeah. Okay. We have. Oops, sorry. We have a baseball. It's being thrown 24 meters per second towards Guy. He got a bat. That does not look like a bat. Okay, he has a bat. And it makes a collision. Boom. Then we have a after. Oh, and it's already in kilograms, so they're being nice. He threw the bat on the ground. And he shot it out of the park 37 meters per second. Okay, let's say going away from the batter is positive. So we're gonna set up our J is equal to delta P. Then we have J is equal to 34 meters per second times 0.14 minus brain fart. This is 37. Minus 24 meters per second times 0.14. J is equal to 37 times 0.14 minus J is equal to 8.54 Newton meters. And then we get F Av is equal to 8.54 Newton meters divided by 0.015, and we get F average is equal to 569.3 repeating newtons. Okay, we're correct, but this isn't in Newton meters. This is in kilograms meters per second. KGM. KGM. KGMS. I don't like how close these two are. Sure, that works. Okay, theta is equal to 60. Length. Wait, oh, okay, the length is 2. That's the ground. Okay.
It is equal to 60. Plus 2 cosine 60. Cosine 60, that's like... I'm not gonna make an assumption. No, it is 1. Okay. So we know that y total is 2.5.
We could just cancel the 5s.
Now, really, what is this y final?
What is this? So we know that y total is 2.5 meters. And then I'm sorry. So we know that 2.5. Oh, y final is equal to 0.5. 0.5. And how we get this is because, sorry, we know that this length is 2, right? So 2 plus question mark has to equal y total. Has to equal that. So it has to equal 2.5. So question mark is equal to 0.5.
And I know we shouldn't use question mark as a variable, but it's so damn fun. It's so damn fun.
I'm going insane. Okay, so y final 0.5. So v final squared over 2 plus 9.8 times 0.5 is equal to 1.5 times 9.8. And we get v final to equal, let me whip out my magic calculator, 1.5 times 9.8 minus 9.8 times 0.5 times 2. Take the square root. V final to get 4.43 meters per second. Bow. Bow wow. Yeah.
Let's verify our answer. Shoot, we're gonna just transition back to my face. Sweet. Make this easier on ourselves, why don't you say?
Okay. Sorry, I gotta check the email I sent to my professor. Hopefully he got back to me. Okay, cool. All right, my professor got back to me. He said I was correct. In my assumption that one of the velocities should be negative for that problem. So good. Okay, we're gonna transition back and do the last problem. Okay, sweet. So we have a box of mass m. Oh, this is just like the question we did like not too long ago. Assume the kinetic frictional force has a magnitude of 8 newtons and D is equal to 3. Okay, so what is the work done by F? All right, it's going to be pretty simple, right? The work done by F is WF is going to be the force of friction. So 100 newtons. This is real interesting. 100 newtons. Let's draw out a free body diagram. So it's on the incline. Normal force always goes against it. mg. We're going to have the frictional force directly F sub k, directly opposing it. And then I guess we have this at angle 30. Yeah, at angle 30. This is our F. Okay, so what do we need to know here? The work done by F is going to be 100 times, sorry, thinking, not thinking, but like going through it in my head, or going through it mentally. So it's going to be 100 times cosine. No, it's actually going to be sine of 30. Then it's going to be times sine of 30 times d, displacement d, which is 3, times cosine of 0, which is just 1. And you get WF is equal to, actually, we'll just put it up here, is equal to 100 times sine of 30 times 3 is equal to 150J. Sweet. What is the work done by mg? So mg is going to actually oppose, in this case, at 45-degree angle. So WMG is going to equal that is going to be 45. WMG is going to be 5 times 9.8 times cosine of 45 times cosine of negative of 180, that goes to -1. WF sub k is equal to 8 times 3. Oh, is this also going to be times 3? I think it's also times 3. Times cosine of 180, which goes to -1. Wn. So, fun fact about Wn, it's going to end up being cosine 90. So, it's just going to go to 0. So, cosine 90 goes to 0 equals 0. And then we'll get 5 times 9.8 times cosine of 45 times 3. Get about 103.94 joules. Negative, make that negative. Then we're going to go 8 times 3 minus 24 joules. And that is 0. Cool, let's double check our answer real quick. Zero is good. So -24. Okay. It appears to be correct. I hope it's correct. I hope I did this correctly. So, yep, that looks correct. And we're now going to use El Baño. Switch back to the face cam, and then we'll go I'll be back. I'll put on some music for you guys before I go. That sounds like ad music. jacket. Not a jacket, more like a study mode. That's actually a pretty good song. Okay. We also had ChatGPT make us a little study guide last night. So, we're gonna actually do that right now. Oh, I look weird with the headset on. Anyway. ChatGPT, we'll go to the study guide that we printed out yesterday. It's a long study guide, wow. Dude. Okay. I mean, let's just like go over our equations. When momentum up is not conserved. Sorry, we're gonna get the music. Okay. Anyway, so when energy is not conserved, we know that WF other is equal to, well, technically it's delta KE plus delta PE, or WF other is equal to 1/2 MV final squared plus MGY final minus 1/2 MVI squared plus MGY initial. And then when, let's write a little red line underneath it. When energy is conserved. We have 1/2 MV final squared plus MGY final is equal to 1/2 MV initial squared plus MGY initial. Now we have big boy momentum. So we know that J is equal to delta P. And we know that J is equal to F average times delta T. And we know delta T, or delta P, to be mv final minus mv initial. And then we have conservation of momentum. So conservation of momentum happens when, so, okay, what do I remember? Conservation of momentum is when m1 v final 1 minus minus m1 v final, or the initial 1, is equal to m2. No. This is incorrect. This should be m2 v final 2 is equal to m1 v initial. This should be plus m2 v initial 2. And then we're going to double check with momentum. Okay. Now we got to know the elastic versus inelastic collisions. So if we have a, what's it called? Elastic collision, energy, and we need to know a little bit more about elastic, inelastic, and perfectly inelastic collisions. So I know one of them is simply, like, as simple as you can get it, that m1 plus m2 times v final is equal to m1 and m1 v initial 1 plus m2 v initial 2. I know that's one of them. Need some water. Could use even more water. My voice is I have dry throat. Getting a little sick, I think. That's unfortunate. That really is unfortunate. Anywho. So, okay, what's up next? We have elastic collisions. This is perfectly inelastic. That's what that is. Okay, let's actually just like straight up look up the difference. My typing skills are not the best.
What is the difference between elastic perfectly elastic, perfectly okay. We probably could find a organic chemistry tutor YouTube video. That I'll just watch and take notes on. I'll mute up, and you guys can just hear me as I listen to the video. You guys will also see the notes that I take, so don't worry. I'm pretty sure this is perfectly inelastic. Don't quote me if I'm wrong. This is like something I could brush up on, and it would genuinely help me a lot. Um, and inelastic collisions. Okay. Okay. Much better. I'm sorry if you can hear it. I always want to try these problems by myself. 4 kg. 5 meters per second. Strikes a 2-kilogram ball at rest. Calculate the velocities assuming a perfect elastic collision. What equations do we need? Okay. Okay, I see what he's doing. So this is just a classic setup. So it's M1 V1 plus, well, actually, let's say V final 1 plus M2 V final 2. Ah, M1 V initial 1 plus M2 V initial 2. And then guess what we know? We know that this is 0. So we know that M1 V final 1 plus M2 V final 2 is equal to 4 times 5.
kg. And so we know that this is equal to 20. So ow. So okay, now we have our original equation. So we're gonna take this original equation, two unknowns, two equations, two unknowns, and we're gonna solve this for v final 1. Or we're gonna solve this for m1 v final 1. So v final 1 is equal to 20 plus 2 times v final 2 divided by 4. Now we plug it into this one. 4 times 20 plus 2 times v final 2 over 4 is equal to 20. That cancels with that. Then we get 20 plus 2 times v final 2 is equal to 20. I think we've dug ourselves into a hole with this one. I think we have dug ourselves into a hole with this one. Let's see what organic chemistry tutor thinks of this video. Or thinks of this. Grammarly commercial. Okay, so he ends up getting this expression, which is pretty valid, I would say, because he's the OChem tutor, and we believe him with everything. Don't know why I erased the 20 here. So he ends up doing for the final 1 plus 2, the final 2 is equal to 20. Then, well, he divided both sides by 2, so 2 v final plus v final 2 is equal to 10. So you get v final 2 is equal to 10 over 2v final 1. And then now you get 4 times v final 1 plus 2
10 over is equal to 20. That 2 cancels with that 2. And we have 4 v final 1 plus 10 over v final 1 is equal to 20. What can we now do that's like pretty easy? No, I don't like that. Have we algebraed ourselves into a whole? No, let's just divide everything by 2. Oh, and then now we get is equal to 0. 2v final 1 squared minus 10 v final plus 5 is equal to 0. And then we pull out our handy dandy TI-84, go to apps, scroll all the way to Polysmith, polynomial root finder, to next. Then we have 2, then we do have minus, then we have 10, then we have plus, then we have 5, solve. Oh, shoot, I forgot. This is going to calculate for... No, just go real solutions. I only want real solutions. I dropped my pencil, aka my stylus. We need to turn on our lights here in a second. Anyway. Solve. So we get it to be the final 1 is equal to about 4.4. 4.44 meters per second. And then we take our original expression. Here we are. Let's just keep it v final 1 for right now, but we know what it is now. So v final 2. Okay, we're gonna actually have to write out the decimal value.
Oh, there's a store button. Okay. So 20 divided by we get V final 2 to equal 0.56.
Actually, I kind of want to know, is this the other answer? It is. Okay. That's weird. Well, I mean, it is conserved. It is technically the same equation. It is saying that. I guess it is saying that. That's weird. I don't like that. I don't like that one bit. I did it wrong. Damn it. Ah, man. Okay. 1 kg bowling ball. So we have a bowling ball, 1 kg. Moves to the right. 2 meters per second.
hits a stationary bowling ball. 3 kg. What will be the final velocities of yeah. Okay, let's find out. Yep. Yeah. And we know that this is just going to be 2. Okay, yeah. Oh, no. No, mass would be 1 times 4. Get it to be 2. Oh, what's mass 2? Mass 2 is 3, right? Mm-hmm. So now we take this equation. Oh, I didn't even write it out. Okay. Oh,
Oh, oh my gosh. Dang. Dang. Dang, dang, dang. So 1 times 2. MV final 2. For both sides. Combine like terms. We get I did something wrong. Dude, what? I messed up somewhere. That's annoying. I understand it conceptually, though. I do understand it conceptually, though. Oh my gosh. Oh, I need to turn on my lights. I don't want to stand up, though. Struggles, struggles, struggles. Give me a second. I'm gonna go turn on my light. Ah, ah, okay. So, so perfectly inelastic. Perfectly elastic. They move together. Partially inelastic. Partially inelastic. Hmm. What the hell? I'm gonna just like look at my physics lab from last week. Okay. I remember a lot of our data. It's fine. Ah, man. Okay, sure. Yes, because when you multiply a scalar by a vector, it becomes a vector. Mhm. Oh, I'm sorry.
Yup, impulse momentum theorem. J, but okay, whatever you want to say. Yep, delta P. Mm-hmm. Mm-hmm. Okay. So it's going to be the definite integral. It's actually time. Okay. Mm-hmm. Yep. Easy. Mm-hmm. Mm-hmm. No, just yep. Yep. I know. I dropped my pencil, but I caught it.
Mhm. Yep. Toss you up top now. It's conserved. Not conserved. Mm-hmm. 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 Yep. Yep. Let's skip ahead a little bit. I need a little bit of a break. It's hot. We're gonna open up a window. Let's go full cam. It's quite hot. We're gonna open up a window or two. Get some fresh air in here. Oh, we're gonna have some almonds, some water. Have some almonds and some water. Oh my god, I have dust on my keyboard. We're watching the video still. Yep. Yep. Mm-hmm. I'm agreeing with what he's saying. Okay. Mm-hmm. Yep. Yep. Mm-hmm. Mm-hmm. Can we do this algebraically? Yep. Mm-hmm. Dropped an almond. Yep. P2. Yeah. P2 prime. Mm-hmm. Yep. M1. Oh, M2 V2. Yeah. Yep. After the collision. Mm-hmm. Mm-hmm. Yep. Yep. Mm-hmm. 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 It's gonna be roughly 12 times 35. So it's gonna be about is it 4,200? 4,200 times 100. It's gonna be about 42,000. So 42,000 versus 45. 42,000 versus 45,000. It's gonna be the truck moving at 15 meters a second. Yeah, it is the truck. Uh-huh. Obviously. Or 42,000. Mm-hmm.
3 kilogram block moving east at 5 meters per second. Hits a 7 kilogram block moving west at 6 meters per second and a 5 kilogram. What is the total momentum of the system? So it's going to be 20 plus 15. So it's going to be 35. 35 minus 42. So it's going to be -7 kgms. -7 kgms. Yup. 5 kilogram block moving east at 6 meters a second, and a 6 kilogram block is moving north at 4 meters per second. And find the magnitude and direction relative to the x and y axis. Oh, x axis. Okay, so this one is super easy. It's gonna be 30 I hat kilograms meters per second plus 24 J hat kilograms meters per second. Oh, and then he's gonna do angle theta. What is angle theta in this case? Oh, okay. So 30 squared plus 24 squared. So it's gonna be 900 900 plus 24 times 24 is just the same as 12 times 2 times 12 times 2. So it's going to be 144 times 2. So it's going to be 288. 288 plus 900. You're looking at 288 plus 900. You're looking at 1188. The square root of 1188 is going to be like 10 times 1188. $1,188. It's gonna be like 18 squared. It's gonna be like 18 squared, right? Oh no, 38 squared. Oh, I was way off. I was way off. Okay, so 200 Newton force acts on an object for 3 seconds. What is the impulse acting on this object? This is super easy. It's just 200 times 3. It's gonna be 600. Hmm. Yep. Yep. Okay. A force of 300 newtons due east acts on a block for 4 seconds. The block was originally moving east at 10 meters a second. Calculate the impulse. Determine the change in momentum. Calculate the final momentum of the block. What is the final speed of the block? Wow. Oh. Oh. Ugh. Oh, I got a bunch of stuff stuck in my teeth. Holy. Oh. Anyway. So it's going to be MV final minus MV initial. So initially moving 10 meters per second, 10 times 60, 600. So 10 times 60, so 600. So it's gonna be minus 600, but then it's gonna be, um, then it's gonna be 300 times 4. So 1200 divided by 60, you're looking at 200. So 200 minus 600, you're looking at negative 400 meters a second. That should be it. Mm-hmm. Yep. Yep. Oh, it's add, not subtract. It's actually 1800. If I did that algebraically, I could have worked it out. I'm hungry, dude. I'm really hungry. Yep. 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 What's 15 times 8, chat? I'll save you the quick math skills. It's 120. So 120 divided by 4. Come on, chat. We're not in first grade. It's 30. 30. Mm, 30 newtons. Our golf club exerted the outer horse of 1500 newtons while it struck a 50-gram golf ball from rest to a final speed of 40 meters per second. How long was the ball in contact with the golf club? Okay. So it's going to be 0.05 times 40 divided by 1500. And then it's going to give you your time in seconds. 0.05, I probably can't really do it right now. Um, Actually, no, that's a lie. So it's going to be 2 divided by 1500. What's 2 divided by 1500? If we multiply the reciprocal. No. Not a good idea. What's 2 divided by 1500? I'm lazy. Uh, Backup calculator. 0.0013 repeating. So 0.001 seconds. Sweet. Should be. Let's see if I'm right. Yep, I'm right. 1.3 milliseconds. I don't like this conversion shit. It's making me actually have to think. So 0.3. There's too many negatives to do in my head.
Give me a pen and a paper. I will be set though. Okay, I'll tell you what it is though. It's gonna be 50 times 0.3 plus 0.3 times 20. And then all that divided by 20. And then that's the average force. And then the impulse would just be that average force multiplied by the time. Yep, easy. The car moving with mass m, they're moving at speed v. If your mass of the car is doubled and its speed is tripled, what force will the magnitude of its momentum increase? I mean, you have 2m times oh, this is sly. It will just increase by 2 because think about it. Because it's going to be m times v, or it's going to be 2m times 3v minus 1m plus 1v. So you're going to get just m times 2v. So you're just going to get 2. It's just going to be 2. What? Shit? Well, I mean, okay. I guess it's 6. Crazy. That impulse needs to be calculated with I and J. So it's just running. It's just a 4 kilogram object moving 5 meters per second, and it suddenly gets a jolt of 20 meters up in the air. Okay. I don't feel like doing this one in my head. Very salty. Very salty. Oh, very salty. Very salty. All right. Um, chat. I think I need to go get some actual food. Um, instead of taking like a long extended break here, I don't know. I'm debating whether I'm gonna end stream or not because here's the thing: if I end stream, I can listen to the music that I want to listen to. Because on stream, I'm afraid of copyright. So yeah, I'm actually gonna end stream now. Thanks for watching. If you're watching the VOD, because nobody tuned into the stream. Hope you have a great rest of your day.
wish me luck on my physics test tomorrow. I will be studying more tonight. I'm just gonna go wash up, get something to eat, and then continue to study. So peace.